So this one is called a cross-site request forgery attack. Okay. Now, what is actually cross-site request? We talk about the request, but what is actually the cross-site? Okay. So cross-site request is you are here. This involves two sites. Okay. Cross-sites always involve two sites. So I'm just putting the one website here and Facebook as another example. And now this is your browser. Okay. You may have different tabs. Okay. So on one tab you are visiting Facebook. So you have already logged in. You have an active session. Okay. So that's active session. And that means there's a cookie. Session cookie is already established between you and Facebook. Okay. And for this website, if you're just visiting this website, okay, and you're going to get a page, okay, and these are not cross-site. But what if you inside of this website, you send a request to here? Now we're talking about send a request from this page, not from this page. If you send a request from this page, that's normal. Okay, we call it SameSite request. Now if you send a request from another page, okay, which belongs to another server, and this is called a cross-site. Now the question is, should the cookie be attached? Should the session cookie, which is you already created, okay, by the Facebook and for this browser, you are using the same browser. Should this cookie, the same cookie, be attached or not? So yes or no? Okay, so why yes? Why do we need to attach the cookie?
Because the attack needs to know who is communicating.
Okay, so what if you don't attach the cookie? What's going to break? What's going to be broken?
Session will be broken.
The session will be broken. Give me an example. What kind of application will not be supported? Well, let's use Facebook as an example. If I don't attach a cookie, think about you use the Facebook, right? So what kind of Facebook functionality will be broken? The like button, yes. Like button is a cross-site request, right? You put the like button not in. I mean, you do put it inside the Facebook, but mostly you put it in some other site, right? And you have another page like SU page. Inside it, you have a like button. When you click the like button, what's going to happen? A request is sent into the actual Facebook from inside of your SU page. That's the cross-site request. Now, if you don't attach the cookie, what's going to happen? They don't know who you are, right? Facebook doesn't know who you are. Facebook knows somebody liked this document. They just don't know who liked this document. They cannot put on your wall, right? So you do need to tell the Facebook the cookie, okay? So basically the browsers will attach the cookie for you, okay? Otherwise, a lot of these will be broken. So browser will attach all the cookie that belong to Facebook if you go to Facebook, whether it's from the same site, from the page, or from this page. It doesn't matter. As long as the request is sent from your browser to the server, okay, it doesn't matter where it comes from. Cookie will be attached. Okay? So that's the behavior of the browser. Now what's going to be the problem? If this allowed, what's going to be the problem? Any risk? This is a design decision made by this, okay? Of course, because of cookie things, okay? We have to use a cookie, and because the web is stateless, okay, we are forced to use cookie. Now we are forced to make this decision. Okay. Now, what could be the issue?
Someone else is in control of the commands that are being issued to Facebook on your behalf. So.
Very good. So, on this page, if can this request be generated by this page? In actually the like button, you have to click the like, right? You have to click the like button. to generate a request. Now the question is, if the page is malicious, and they can generate a click for you, right? They don't need you to click. They will just directly send a request. They can just write a JavaScript code to send the request to the server. And they don't need to wait for you to click. Now that's a problem, right? Now, how does the server know this request is generated by the click, user click, or is it generated by this code? How do they know? They don't know. That's equivalent to the server. Okay. Now, if they don't know, they got to know whether this is from. If they can know whether this is from this side or from this side, that can also help them. Okay. If they know this is actually the request from their side, from their page, that is more trusted, right? Because the request is generated from my own page. I should trust this more. Now, if the request is generated from another page, okay, I shouldn't trust that more. Okay, I will trust less. I may still trust a little bit, but I wouldn't trust as much as I trust my own page. But how do I know where the request is generated? How does the server know? Okay, referral field is one of things. Okay, because when the request is sent, there's an additional field which says where this comes from. Okay, so that is one of the fields that we can tell. But unfortunately, remember the referral field is used for advertisement, and a lot of browsers and the extension they actually wipe out that referral header. Okay, so to protect your privacy. Okay, because you don't want people to track you. That's one of countermeasures against the tracking. So that becomes not reliable for server. Okay, so this has become a problem. Okay, so now there's no actual reliable way, okay, automatic way, systematic way for the server to tell the difference. Okay, that's going to cause problem. Okay, so let me just show you what the problem is. You're going to do this in your exercise. Okay, so here, and for this lab, we actually have we use the ELGG. It's an open source social network, the platform, just like Facebook, but it's open source. So we have installed the entire thing on our computer, on the VM. Okay, so and we can change the code. So here, and this is the kind of platform. Okay, so let me just log in. Okay, I can log in as I'm just logging as Alice. Okay, we have created several accounts. Okay, all the username password is actually in the description. Okay, so I log in as Alice. So I'm in Alice account. Okay, so and you can see there's no friends. Okay, so just this is the Alice the profile. Okay, so now adding a friends is a request. Okay, if you want to add a friends, so let's say I just want to add a friends. So I'm going to click on it here. I have several other users. If I say I want to add Bobby to my friend list, okay, and you can see there's a button, right? So if I just do add friends, what it's going to trigger is it's going to trigger an HTTP request. Okay, so this is going to trigger. Now the server now is going to have my session cookie. The server knows I'm Alice. And the server knows I want to add the Bobby to my friend list. Okay? And the server will add. So if you go back to my friend list, and you can see Bobby now is on the friend list. Okay? And because server actually does verify. What if you can generate this from another user, from another web page? Okay? So let's see. So now I just show you let's just use ELGG as the example. Okay, I was in the ELGG web page. So I add a friend. Add a friend is going to generate a request to ELGG server. Okay, we put the ELGG server on the local machine. Okay, so and we did create some URL for that. So it looks like from from outside, but it's all, the server is running on the same machine. Okay, so, and you send a request to that, okay, and that request contains a session ID. And that request is something, and then the action and add, and then there's a parameter name equal to ID. They put each user is to have ID. Okay. So that means you want to add 42 to your friend list. And this is a request sent. It's a GET request sent to the server. Server is going to look at the session ID first, making sure this is Alice. Okay. So verify this is sent by Alice. Okay. And then they will add 42 to the friend list of Alice. Now, what if Alice, this is the Alice actually. Alice is a computer. Now, Alice is actually also visited another page. Okay, this is another attacker.com. Now, why Alice is in that attack.com? What if this attack.com send out the exact same request? Exact same request like this. And then because the browser is the same browser, the browser is going to attach the same cookie in here, right? Now, should the server add this to Alice the friend list or not? The server doesn't know the difference, right? The cookie is valid. Request is a request. Okay, so the server will actually add this to the friend list. But the question is now, this is not triggered by Alice. This is triggered from this page. Okay, they don't need to have a button, and all you need to do is to write some code to send to the server. Okay, for GET request you don't even need to write a code. Okay, so the GET request is much easier. Okay, so you can actually, by doing this, you can send a request from another web page, okay, as long as Alice is visiting this web page. Okay, so this is called the CSRF, okay, the cross-site request forgery. This is a forged request. And if you don't have a countermeasure, if the server doesn't have a countermeasure, and you would add this to the friend list. Okay, I will show you that. Okay. So let me just remove Bobby, okay? So just remove friends, okay? So now there's nothing here, okay? So now I'm going to actually, you can send an email to Alice, or you can send some message to Alice and ask Alice to check a website, right? That can be, you can easily do that. You can send an email, check this out, right? That's a link, okay? So I will skip that part. So you have to find some social method to get Alice to visit you this page. So I'm already done that. Okay. So Alice, I assume Alice is going to type this. Okay. This is the page I want Alice to visit. I will send to other social networks, Facebook, whatever they mean. I want Alice to go to this page, and so I'm going just to refresh this. Okay. So there's nothing in here. Just welcome to this page. Okay. And so before that, let's just see whether there's no friends, right? Still no friends. Let me see whether my attack works or not. So Alice is going to just visit this page. Okay, this is a different page. ELGG, this is the ELGG page. CSRF lab ELGG.com. Okay, so, and this is the CSRF lab attack.com. Okay, and this is a different website now. Okay, so if I refresh this, okay, so, and you can see now Sammy is added. Okay, Sammy is attacker. We use Sammy as attacker. So all we need to do is for Alice to visit this page. So let's do it again. Okay, if it's too fast. Okay, so remove friends. Okay, I'm removing this. Okay, no friends, right? So and now Alice just need to visit this page. Okay, and I'm just I can do it in a different tab. Okay, doesn't need to be here. So, and now Alice gets to this page, right? inside of this page, I trigger the request. I send the request. I will show you what the code looks like. Yeah. So, and you go back to this Alice again, go to here, and this is Alice. Okay. So, basically, all I need to do is trick Alice to visit this page. From the page, and I send a request, forgery request. So what is in that code? And if you just look at view page source, so I will just show you the code actually. Okay, and this is actually the web page. I don't even have a code, right? What I do is I embed a picture inside. I embed a picture. All I need to be able to generate a request, right? We know the picture is going to generate this is a get request. Add friends for the ELG is a get request. Okay, so all I need to generate a get request. I know the picture can generate that. So, and you can see I've set the width and height to 0. So you don't even see the picture. Okay, but the source is from here. And you can see it's an action friend add friends equal to 42. 42 is the sending. That's the attackers. Okay, so that's how easy it is to really to launch this CSRF attack if you don't have a countermeasure. Okay, yeah. Later on we're going to talk about the countermeasure is not that difficult, but it just if you don't realize this, and you can easily make this mistake. Okay, for telnet we never thought about there's a cross telnet attack, right? We never heard about that. So because there's no such session things, right? So okay, so that's just the get request. Okay. Now, what do we want to do next? Is we want to this one I will not demo. Okay, because this one is more tricky. I want to do as a lab. Okay. The previous one you still have to do for a lab, but that's very simple. This one we are targeted at the post service. So we talk about the get. Get, I don't even need to write code. I just generate a request. Post is different. Okay, post is a little bit more difficult to do. Okay, and inside of this actually, there's the profile. If you want to update the profile, you need to send actually the post request. Okay, so in this attack, we want this attacker to modify Alice's profile, to change whatever's inside the profile. Okay, so that's the goal. Okay, so of course you want to use the same technique using the forged request, but the challenge here is a post instead of a get. Now this is the get request. Okay, so one thing I want to mention here, this part you don't need to worry about this part. Okay, for this lab, because this is the countermeasure. I will explain the countermeasure. So, and the browser will send this to help the server to know whether it's forged or not. Okay, but inside the server we disable the verification. So even if you don't attach this, it doesn't matter. Okay, so but we keep the original code in there. So that's why if you go to the ELGG, if you look at the request that's been sent, this is actually been sent, but never been verified, because we turned off the verification logic. Okay, so that's why you only need to do this the first part. Okay, now for the post request, now the question is where do I put this friend equal to 42? That's only the difference. For the get request, I just put this after question mark, and I can use this as a URL, put it in the URL. For the post, you cannot do that. So for post, we are not adding friends, okay? Because add friends is a get request. We have modified profile. Okay, so you can see you got the data is going to be put in here. Instead of putting in this URL, you can see that there's nothing, there's no question mark, there's nothing in there. All the data is going to be put in here. Now if you want to use the image approach only allow you to put the URL, so but this URL is not that useful. You need to attach the data. Instead of data, you want to tell the server, I want this profile to modify based on this data. This is the data that you use to modify this. Okay, so now you need to actually generate a post request. Now, it is not that difficult. So, but you need to know how to write the code. Okay, this is part of code that TA is going to actually talk more about this. So what is the best way to generate a post request? The best way to generate a post request is to send a form, okay, using form. Okay, so now in this attacker page, now if we have this form, okay, if you have this form, and then this submit button, when the user click on this, and this is going to generate a request, okay, and to the server. And you can specify that this form is a post form, post type. And you can specify the URL, so the URL will be that /edit, okay? You want to add a profile. And this is a post. Whatever you fill in here and will be attached as a data in the post request. Okay, so the best way to do that is to be able to send a request in the form of form. Okay, so, but if you just put this form inside this, the user is not going to click that, right? So if you just post a form here and you tell them what is the information, please click this button because I want to modify your profile, right? The user is not going to click. You have to do this behind the scene. Okay, so that's why this whole piece of code, okay, which TA is going to actually explain more about this, is to really dynamically generate this form. That's exactly what it's going to do. The form will be generated dynamically, added to the page, okay, in a hidden style. Okay, all the entries hidden. If you look at some of the parameters here, hidden, all the field. I have name field, I have description field, I have all these fields. Each of the fields corresponds to one field in the profile. And all the information are already filled in by the attacker. Okay, so this is a part of the code. Okay, even though I put something in here, but there's some part you have to figure out. Okay, TA is going to explain the code to you, but some of the field you have to put in. Okay, based on your observation. Okay, so this is just construct a string. Okay, and they actually construct the form is here. This is the content of the form. This actually is how you actually really put the form in. So you can see I have a URL, which is the target server. Okay, I have a post type. Okay, and document.body.append child. That is really to put this in the page. But everything is hidden. Okay, the user actually doesn't see that. Okay, all the field is hidden. All these forms are hidden form. Okay, and then it will submit. Click. This will emulate the click, and you don't need to click. This p.submit is going to submit automatically for you. Okay, and your job in the lab is really to figure out what to put in those places. Okay, and we'll provide a skeleton to you. Okay, the code skeleton is going to be given to you. Okay, but you should be able to figure out mostly what to put in here. You need to write another page. Okay, so right now I have a task 1. You got to write task 2. Okay, your task 2, you need to put the code in the task 2. Okay, the job is to generate a forgery request sent to the server. And so if you go to the Alice, that's edit profile. Okay, if I do the edit profile, if I'm doing edit my own profile, that's how I do that. After I fill in the information, I will save. When I save, I send a request to the server. And you need to generate the same request. Okay, not from Alice's page. Okay, from your page, the one that you put in the attacker.com. Okay, and you just need to actually let the Alice to visit this page. Okay, and then you're going to show us that the profile got modified. Okay, and we ask you just put Sammy is my hero in the profile. Okay, and that was the story behind that, and we'll tell more about when we get cross-site scripting attack. Okay, and that is the Sammy is my hero, and that is what came from the real attack launched by Sammy. Okay, that was the next attack we'll talk about around 2005 in MySpace. He basically launched this attack. He added himself to the friend list of over 1 million users, okay, automatically. Okay, and the user don't know that, and he's on the friend list of all these 1 million users because of his attack. He wrote a worm. Okay, that worm basically actually affected millions of users. And if you're affected, you will add Sammy to the friend list. Your profile will say Sammy is my hero. That's a story. That's why we're just trying to duplicate that. But you can put everything you want, okay? And that's just like. So I want to talk about some of the countermeasures against the CSRF attack. By working on the lab, you probably learned some of the countermeasures. Okay, but I want to just systematically to look at, and if we develop a countermeasure, what kind of countermeasure can be developed. Okay, and you only get from the lab, you learn about one, but I want to actually and help you to really to see, and there are many other countermeasures. Okay, the one that you are working on is just one of them. Okay, the important thing is to learn the idea. Okay. So, in order to understand the countermeasure, so the most important thing is to understand what is the fundamental cause for the CSRF. Okay, for the CSRF, when you log into the Facebook, okay, and then there are the cookies, okay, special session cookies, and they will be actually stored on your browser. Okay. So next time when you go back to Facebook, and all this cookie will be attached. Okay, the most important cookie is a session cookie. That will tell the server that you have been authenticated. So server won't ask you to type the password again. Okay. Now the problem is, if you happen to just visit another website, okay, and you get a page to your browser. Now what if this page actually sent a request to the Facebook? Okay, and this is called a cross-site request. Now the browser has to attach the cookie, okay, because the request goes to Facebook. So the cookie that you obtained from here will also be attached in this request. Okay, so the cookie will be here. Okay, and that makes it difficult for Facebook to know whether the request is from its own page. This blue one is from the Facebook's own page, and this one is from somebody else's page, untrusted. Okay, now Facebook is going to have a trouble to identify which request come from my own page. If the request comes from my own page, I trust it, because generally from my own page. If from other pages, I don't know. I mean, I don't trust whoever developed this page. They can also trigger the same request. So that is a problem for the cross-site request forgery, because the browser does not provide this kind of support. Okay, and they have this referral header. Okay, so if you send from here, the referral header is going to be from this web page. If you come from here, the referral header will be from Facebook. So that information is useful. Okay, Facebook is supposed to be able to detect the sender, but as I said, the referral header is not reliable. Okay, and many of the browsers, they will just remove that header. Okay, because it does reveal the private information. Okay, so if I go to your page from cross-site request, I really don't want you to know where I come from. Okay, so that's my behavior, my action. I really don't want you to collect that information. So referral header does have the security and privacy and the consequence. So now, how do we help? Okay, how do we help? And we talk about, actually, one solution is Facebook can do something to help itself. Okay, the typical way to do that is you have to put some secret into your own page. Okay, so that's the secret token solution. So Facebook says, I can embed something secret inside here. Okay, so from my page, I got a secret in my page. Okay, now when you come back, so not only do you need to include those cookies, you also need to include this secret token. Okay, without the token, and I know you come from this site. Okay, with the token, I know you come from my own page. Okay, so that's actually a solution called a secret token solution. Okay, and that is the one that actually ELGG used. Okay, so if we look at the actual the setup, okay, for ELGG, for the form, okay, so for the post request, usually they are generated by the form. So inside the form, they always have these two hidden input. Okay, so whenever you click the submit button, okay, a form is going to be submitted, but there are two actually the secret field inside. Okay, the value and will be filled up using the secret embedded inside of the page, and that's why when you send a post and you do see these two additional fields. Okay, that's the token. Okay, so all these forms inside of ELGG, they have these two embedded hidden fields. Those are hidden, so you don't see them. User do not see them. Okay, and we also talk about it in the GET request, and you also have to attach that in the URL. Okay, so similarly, so without that, and you won't be able to pass the verification. On the server side, so in the server side will verify these two secret tokens. Okay, the timestamp and that token. So if you look at the code, it's going to get ELGG token, get the ELGG underscore timestamp. Okay, and then it's going to do some verification. Okay, so if verification fails, okay, and you will not go to the next step. Okay, so that's actually the defense mechanism. Okay, they embed some secret inside. Okay, now what I want you to think about, what could be the other solution other than embed a secret? What could you do? What are other ideas that you can have? Yes.
Maybe add some port information.
Mm-hmm.
I mean, how does Facebook actually differentiate between two pages? Let's say two tabs that are opened on the same browser. One tab asks for the friend list. One tab asks for some settings page.
Mm-hmm.
Facebook knows how to reply for each one of them, right?
Yeah, yeah.
So, I mean, the same way that Facebook knows how to reply for each one of them.
So so what kind of other mechanism and can be used to differentiate whether requests come from your page or come from other page? Let's focus on that question. So let's not worry too much about Facebook. Okay. So any server, okay, we know we can use secret token. That's one solution. Okay. Other than that, so how can I tell when I get a request? Okay. How can I tell and whether this request comes from my page or from the other page? That's all I need to know. Okay. If it's from my page, it's more trusted. I can give it more the more privilege. Okay. If they want to delete friends, I will do that. If it comes from the page, if that page you want to delete friends, I wouldn't do that. Okay, so that's kind of the things I need to know, and in order to actually make a better decision. Okay, so think about what you can do. You're allowed to modify browser. Okay, you are allowed to have a blue sky thinking. Okay, so not only just say within the current system. What if you are the developer of the browser? What if you are developer this entire web technology? Right? What other idea could be used? All we need to do is to help the server differentiate between the request from the same page versus a request from another page. Okay? So, yes.
Session ID.
Session ID, how do I tell? Session ID is in here. Okay? So if you send, the session ID will always be attached. Whether the request comes from here or from here, it's always going to be attached, unless you want to make some change. Okay, if you want to make some change, you may actually break. So you make one decision is not to attach the cookie, not to attach cookie for others page, for cross-site request. Right? That will solve the problem. So if you are cross-site request, and the browser knows this request going to Facebook is generated from malicious.com. Okay, so and the browser can make a decision not to attach the cookie. The consequence is you're going to break a lot of functionality, right? So you can go to one extreme by allowing the browser to attach all the cookie, or you can actually say, I'm not going to allow it. There's two decisions. Now the question, you can come up with something in the middle. So you could solve this problem, but without breaking the functionality. In the browser. Think about, you can modify browser. You can redesign the browser.
So why don't the browser check for decision ID and decide accordingly whether to attach the cookie or not?
So how does the browser make that decision? How does the browser know whether it should attach or not? What give the browser?
Who issued the request?
Facebook issue. Facebook says, I have this. That means all the requests coming from here, okay, and the browser need to attach that. Otherwise, I'm going to ask the user to type the password.
I know, but the other website is the one that issued that request, right?
Yes.
The browser knows that. Facebook might.
Yes.
But the browser knows it.
Yes, browser knows. Yes.
So the browser can make the decision. It's not related to Facebook.
I know, but now think about, there's two decisions, right? A, send, right? B, don't send. Okay, now tell me how can the browser make decision, choose one. Send, you're going to have a CSRF attack. Do not send, you're going to break functionality, right? So either decision, you have a consequence. Okay, now assuming we don't have secret token, okay, we're not. So right now, the decision is made to send, always send the cookie. And if you want to switch to this, it's always not send, you break things. Okay? So that's why I don't understand. Yeah.
Browser knows the URL from which the request is.
Browser knows everything. What the browser doesn't know is either way, that's going to be a consequence, right?
I mean, the browser can check the URL. If it belongs to the target website, it can decide to send. If it does not belong to the
No, browser knows this is cross-site. So the decision, the browser knows this is a cross-site request for sure. Okay, and the URL definitely, the URL of here is different from here. Browser knows that.
Yeah.
So browser knows this is a cross-site request. Now the question is, for the cross-site request, send the cookie or not send the cookie. What's your decision? Your browser now. Make a decision.
I won't send the cookie because it's from somewhere else.
What do you mean? If you send a cookie, you only send Facebook's cookie. You don't send other people's cookie.
Yeah, but you send the cookie that's opened by another session on the same browser, right?
Not the other session. In here, the tab in here.
Yeah.
You send the request right from that tab, that session. Okay. It's just that the cookie is always saved in the browsers. Cookie is not attached to the tab, attached to the browser. If you don't send a cookie, then Facebook is going to ask you to type the password. That's the consequence. You can do that. Yeah, if that decision, you will type the password. I mean, you can still continue on. Okay, but the user won't like it. Okay. Yes.
Like first the browser make one request and check the original URL is trusted or not.
How do you know it's trusted or not? Just a URL?
Yeah, it will first send a request to Facebook to check if that URL is trusted or not by Facebook.
Oh, okay. So you're saying the browser will talk to the Facebook and asking whether the browser is trusted or not.
The URL is trusted or not. Yeah, this website is trusted or not.
Okay. So that will work. Okay. It's just so complicated. It's going to be complicated. Yeah. In that case, why don't you just send the URL in the request, the referral header? That's exactly what the referral header is for. What you are saying is just different way to send the referral header. That's going to break the privacy. Nobody likes it. That's exactly the purpose of referral header, right?
So
yeah.
you do not
You don't want that because this
You
that's
can't achieve that only browser-wise. I mean,
Yes.
the browser itself, if something that's not Facebook that
Yes.
issued the request, the browser knows it.
Yes.
It's contacting Facebook.
yeah, yes.
So it can decide not to send the request.
No,
to
the question, the Facebook wants the cross-site request. Facebook wants that, right? If Facebook doesn't want that, yes, you can ask a browser. But Facebook said, I want that. My entire like button is depend on that. Without that, my like button doesn't work.
Why? The like button is part of Facebook.
No, it's not. You embed your like button in other people's page. That's how it works.
In other website, we can
So
add like button.
I create a page, I embed the like button in my page. When you click on that, you send a request to Facebook from my page, not from my Facebook page, my syr.edu page. So it is needed. That's why, I mean, the internet is, I mean, depends on the cross-site request. We cannot just forbidden the cross-site request, okay?
What I'm thinking about is Facebook and whatever website can agree on a particular key to send information. Like, say the browser and Facebook, if I'm sending a request from that site, I send the key, Facebook communicates to the browser, and Facebook should know who's sending the request, and then only they agree on a key, and then they make a communication based on that key. So if Facebook doesn't...
So, as I said, we don't want the Facebook to know and this request because otherwise we are breaking the customer's privacy. So if I tell the Facebook, we go back to referral header. We already have a solution, but that solution is not practical. There's a lot of extension people install to zip out that referral header. So the solution is there, okay? It just, we cannot tell the Facebook, oh, this request come from here. Do you want it or not? Okay, that
Basically, it shouldn't be a browser.
it shouldn't be a browser decision. That's good conclusion. Yes.
What if you have a third-party solution to this, like a third-party solution where a list of websites that are trusted are stored,
Mhm.
but you're not sending information like the referrer header from the third-party solution?
Okay, so
So Facebook and the third-party application will talk to each other and agree on a list of websites that can be trusted. So
okay, so now let's go back to the referral headers idea, right? So let's modify the referral header. Okay, let's make a proposal to improve the referral header. The referral header, the problem is I'm telling you too much, right? I'm attaching the URL. Let's improve on that. Okay, give me an idea. How can I tell you this is a cross-site request without telling you the URL?
Attach the token into HTTP header.
Okay, there are some much better, much easier solution. So you are Facebook, right? And I'm sending I'm browser. I'm sending a request from his page, the page from his site, and I want to let you know this is cross-site. In the past, I have to attach the URL, right? Now I want to improve on that. We are changing the browser. We can change the browser. How can I change the browser to let you know this is a cross-site request? Okay, so
just add some kind of a field or something which says that it is.
yes, yeah, just tell them this is a cross-site request. That's it, right? So instead of telling you the URL, I'm just telling you when I send you the request, I put another header, okay, the cross-site header, cross-site request header, CSR header, and I put the flag 1. That means this is generated from another site. I'm not going to tell you from where, because it's none of your business. But I'm telling you it is a cross-site request. That's all we need, right? So just to replace that the referral header, okay, and people are concerned about that, that's why we remove that header. So you just put an actual field to tell them this is a cross-site. That will solve the problem from the browser level. And now you don't need to actually implement that token anymore. Because every request, I have that flag. I'm telling you cross-site or not. Okay.
Professor, but then can you, like, if it's a flag 10, then I can still send a cross-site request with flag 0, and then Facebook will say, okay, it's flag 0.
You cannot. The flag is set by the browser, not by your page. Your JavaScript cannot touch that header. Browser is going to attach that header. Just like the cookie. You won't be able to get the cookie. Okay? Remember, you are not able to get the cookie, but the browser can attach cookie. We'll do the same thing. You won't be able to set that header, but the browser will do that for you.
But when we replay the request, we can modify it, right?
What do you mean you cannot replay? If you send another request, browser attach another header. Still is 1. So you won't be able to change that to 0. Okay? Okay? Unless you have like a HTTP header, right? You can go there to change, but that's user, right? If user want to attack himself or herself, right? I cannot block that. So that's a very simple idea, right? So the Chrome, they actually adopt another idea, which I think is very very nice idea. So and this is called the SameSite cookie. So the Chrome and basically says, I'm going to allow the server to decide whether this cookie should be attached or not. Okay? So I'm going to make a decision. I'm not, because you cannot make a decision, right? You don't know whether it's going to break my functionality or not, right? I need the cross-site, and if you decide not to attach cookie, you're breaking my functionality. Let me tell you, I want this cookie to be attached in the cross-site request. Okay, so they actually introduce this is called SameSite cookie. SameSite cookie means this kind of cookie is a special cookie. Okay, so if you have a server here, now from your own page, and they can set this cookie. These are the special cookie now. The other cookie, they will automatically attach, like usual. Okay, now the SameSite cookie, now if you go from here, so this SameSite cookie, now if you generate a request from here, now the SameSite cookie basically says you can only attach if the request comes from the same site. Okay, if this request comes from the same site, okay, Facebook page, attach it. If it's a cross-site, don't attach it. So now there's a 2 type of cookie now. Okay, the session cookie will still be not the same site. Everybody's going to attach the session cookie. But I kind of put a flag cookie. You can consider that's a flag cookie, right? Without that flag cookie, I know it's a cross-site. With the flag, I know it comes from my site. Just exactly like that idea, right? The header idea. You just have a special cookie in there, okay? Now, but you decide, okay? You can put whatever you want in that cookie. Without seeing that cookie, you know definitely this comes from the cross-site, okay? So the idea is very simple, and it's also very, very easy to implement. The Chrome now already implement that, okay? So this is some of the nodes. You can see that. And they do create 2 types of cross-site, a same-site cookie. And they are 2 types. One is a strict. What I just described is strict type. So cross-site will never be able to attach if the cookie is, the attribute is a strict. Okay? And they also allow this lax. Okay? So for certain kind of a cross-site request, they allow you to attach. Okay? So, and these are the few which allow, and this you can. Normal means those are just normal cookie. Okay? So this category, you won't be able to attach this lax type. Okay? The strict type, none of them can attach if it's cross-site. Okay? So the idea is the Ajax definitely you cannot attach. Okay? But if you have a link, so the idea is if this actually the request cause actually your URL to change, okay? So and then they will allow that. They consider that's actually safer, okay? So if you actually switch to another page, okay? So if you click the link and now link goes to Facebook. Now Facebook comes in, you have to switch page, and that is considered as relative safe. But if you do the Ajax, okay, and that is not, okay? So you can read more. I won't dive into too much of this, but the idea is to create something called a SameSite cookie to help the browser, okay, to decide whether you should attach or not, and this way the server knows whether it's cross-site request or not. Okay, so there are many other ideas like this. As I said, in the referral header, the modified referral header, you can achieve that goal. Okay, and this one achieved the similar goal, and this one now is already in there. I think it's just half a year ago was introduced and by Chrome. I think it's this year. Okay, I didn't see the time, but I believe it's this year. Okay. Okay, so it's clear. Okay, a lot of these are actually the countermeasure, and there are actually multiple solutions. So it's not only just one. Okay, what I would like you to do is to be able to think about the other ideas. Okay. Okay, now since we are here, so this is one of the questions that one of students raised. So now he's saying now a lot of these websites, they are using HTTPS. Okay, HTTPS is encrypted. Okay, now the question is, and if the server is using HTTPS, would this attack still be successful? Should they still worry about the CSRF attack? So what's your take? Now HTTP we know, okay, so now if the request, so this one is the HTTPS. HTTPS basically is the traffic going from here to there is encrypted, okay? So you cannot sniff by observing, okay? So yeah, if you have not taken my internet security class, I don't blame you, okay? But if you have taken my internet security class, how many of you? I know you have taken, right? So maybe you're the only one. So then I don't blame you. So because you actually don't have the full knowledge. But after you taken the internet security, you should be able to answer this question by yourself. Okay, I will give you a try.
I asked the question.
Okay, great. That's a good question.
I've been looking for it. It's the only thing about this that you cannot know the request form easily. But as I understood, once you know the form, you can actually make the CRS.
Yes.
The
That's good. Yeah. So
because the encryption occurs after the request is issued.
Exactly. Yeah. So once you know what the form looks like, and you can construct the form, okay, and that encryption really is not helpful at all, right? And now, how do you get the form? You cannot observe this from here. Yeah, but you can go to Facebook yourself, right? You can look at what actual request looks like from your own website, and you can do that. Okay, you can look at the source code, right? The JavaScript code is there. So finding that form is really not so difficult to find. So if I just want to find the form by sniffing this, then I cannot, okay, because that's encrypted. Okay, but if I might also have an account with Facebook, right? I'm just playing with that, and from my own computer, and look at the page source, I should be able to do that. Okay, so basically now let's see if I know the format, okay, that shouldn't be so difficult. I'm still come from here. Now when I say I'm going to actually launch a request, add friends. Let's say add friends. Now it's HTTPS. Okay, I can still construct the URL, right? I can still construct the add, right? And the question friend equal to 42. The URL is exactly the same. Okay, so this is not a secret. Okay, so now when I generate this request, now the browser is going to encrypt for me. So even if I generate from here, and the browser says, oh, you want to go to the server, this server, okay, and you are using the HTTPS, okay, let me encrypt that for you, okay. So the browser, the communication between the browser, okay, and the server is encrypted, okay. So, but when you tell the browser it's not encrypted, you just tell the browser, I want to go here. Okay, now you help me to secure that connection. Okay, the browser is going to work with the server, and they're going to agree upon a secret key. Okay, a key to encrypt the traffic. But you don't need to be involved at all. Okay, and so the page is not even involved. They don't even know the encryption happens. They just tell the browser, I need to go there, and I need to go to the HTTPS server. Okay, so the browser will just do the auto encryption. So it doesn't matter whether it's cross-site or the same site. They basically just tell the browser the same thing. Okay, so this is before the sending the request to here is before the encryption. Okay, so that's why it doesn't matter. HTTP doesn't matter.